devices. But there is a problem with this web application because it's not a native application to the hardware itself. It can be very slow. It can be slow.
Okay, we're back.
You will not have access to some particular functionality unless you have to write blogs for those applications. So that is one and one. So we have multiple applications. Okay, we have multiple application types in device. As long as there's going to be a lot of device, you're going to write different applications. So another thing is that you can write a customer application to a particular hardware, and this customer application that you're going to write for this hardware, for this particular hardware, can be referred to as an embedded application. So embedded application runs. This application runs in a customized, specialized hardware. So the specialized hardware, as we all know, all computers can only work when there is the mega called the CPU, which is referred to as the processors. So
hello, good sir. No, I have family. I work for that side. That is protocol.
To make it more easy to understand, so if I say processors, go to Google, processor. So the CPU is just a layer of chips. So this CPU carry out mathematical functions. So you can use it to add numbers, store values, and these are plenty transistors stacked to one another. They actually can compute particular things within a time. So you can write a customer, you can design your own computer by purchasing one of the CPU, because most of this famous CPU is the Intel called the Intel CPU and the.
Okay, guys. So as I said, now I am going to be talking about blockchain today. Okay, let's see what we'll do. I'm going to be talking about blockchain. Blockchain technology. This is a very, very, very famous thing. About blockchain. So we're going to talk about blockchain today, and we're going to see how we can write an application, see how to write application for blockchain. So if you don't understand blockchain before, I'm expecting that after this talk that we're going to have today, you should be able to have a very good idea of blockchain. And the reason why I'm doing this is not that because there's not enough book out there that will actually teach you blockchain, but also how it really works out there instead of just telling you what blockchain is all about. So our discussion is going to be weird sometimes because, you know, the discussion is going to be more of like, what is blockchain? So what is really blockchain? Because blockchain is a technology, but there are a lot of things out here that this year currently actually blockchain have actually explored, because when we talk about blockchain, we are not talking about Bitcoin, or we are not talking about Ethereum or any other cryptocurrencies. We're talking about the technology that power those digital currencies. So what is blockchain? Let's begin. So one of the idea here is that you can actually revise back and see what the video is, because the video will be published So I won't be waiting for anyone, because if I have to wait, then I will not be able to do this. So the last stream that I did, I explained what an application is. So blockchain technology is a way you create an application. So what is blockchain technology? That is it. The word block, you know, we engineers, software scientists, sometimes they just give the names based on what the thing is doing. Block and chain. Don't let chain. So the word block means there is a block of data, and chain means there is a chain that actually links those block of data together. So you see, we link those data together with a chain. So this is the chain and there's the block. So now in every block there is a transaction. So for example, what is a transaction? Maybe a blockchain technology, the most popular use of blockchain technology is because the kind of block that you're going to be having here is going to be filled with transactions. So the block is going to have its own information. There's going to be, we call the block metadata, because these are data that describe the block metadatas. Yeah, that means the information that describes the block, and the block will have a set of transactions, like someone sending someone's money and you transfer money, transfers, or receive monies. So these are transactions. So every block have a form of transaction. But this is simple, right? This is easy. No, it can't be as simple as this. Yes, you're right. So a set of transaction in all this set of blocks. So there is a list of transactions. There is a list of transactions. Okay. So this is as simple as I can explain this. So we'll go deep a little bit by little bit. So a list of transactions in every block. So this is block 1, block 2, block 3. Okay, good. Now that is what blockchain is. So in each transaction, we will come to that in each transaction to make it a little bit complicated. So now each block, this first block, know about no block, because blockchain is about future. You cannot predict a future transaction. So only the future transaction can know about the old transaction. So the chain goes this way. The chain is from here to here. So the chain of the arrow will be different. Instead of chaining this arrow like this, so you're chaining it backward. So this transaction block 1 knows about block 2 knows about block 1. So there must be a reference that actually refers the previous block. And the previous block is a hash value. I will tell you what a hash value is. Then every block have a hash value. So this hash value is hash based on the content of this particular block. So when the content change and you calculate the mathematical hash of this block again, the hash value will definitely change. So that is exactly why the hash value is very useful, because you cannot reverse a hash value, but a hash value is always same for every block. So to calculate the hash value of this block, so every block have a way of you calculating the hash value. Now, let's say a hash value. We'll talk about hash later, okay? So assume that every block have a hash value. So I'm going to refer to this hash value of this block, which means if anything changes in this block, since I'm referring to it, and I hash it again to try to match it, if you change any transaction, then something is wrong. I will regard this block an invalid. So I will go to the next block and see if I can get it. So if you change the value of each block, you just destroy that block. So you can't change the value. You only can write to a block and you can change the value of a block. So that is the idea of hash value. Let's still continue. So now, in a blockchain technology, there is a common way of there's a common name in mostly this
incurrencies if you've heard about Bitcoin. Okay. Now Bitcoin, they call them miners. So like mining, you're trying to mine a gold. Let's assume we have a block and we have some pending transaction. Nobody have confirmed yet, sending money a lot. So we have millions of pending transactions. And for we to confirm this transaction, we assume that this transaction are valid. We're not going anywhere to confirm the transaction. We just assume that they're valid, but we haven't added them into a block yet. These transactions, we have to add them into a block. If we add them into a block, that means nobody can actually say the transaction are not valid. So you're going to spend once. So while the transaction is on pending, your money is still pending, your transaction is still pending. So there are going to be a miners who are going to create a block for this transaction. So the miners will pick a lot of transaction, pending transaction, and calculate the hash value of the block plus the transaction. So if you can do this calculation of this hash block, which is not a big transaction, I'm going to show you what that means. Then if you can do the calculation of this hash value of the block based on the format that Bitcoin wanted to be. So let's go back to a simple Python code to show you what an hash value is. Because my previous remember my previous video, I play around of trying to show you how computer function works. So this is a particular transfer function, but let me show you what a hash value is. So a hash value is nothing but a simple programming function. So this is what a hash value will do to you. This is what a hash value will do. Open the share. So if I have a content, let me say content, I am Barrow, I can actually hash this value. In Python, there is a library called hash live, so I can hash blockchain. Beacon as a company, the official Beacon himself, the Bitcoin, uses this particular hash. So I'm going to use the hash, which is 256 hash 256. So Beacon uses hash value to do their hash calculation. There's a lot of mathematical functions. This is just a functions, like the way we wrote the transfer functions, but somebody wrote this to do these calculations. So if I take this content, ch256, I think it's capital letter 256. If it's not capital letter, he will tell us. So if it's capital letter, let's say again 256. Okay, small letter. Now we can update the value. We can actually put it here, but I didn't. So now let's just take our content, which is I am Obaro, and put it here. It will only take a string character. So if I want to hash the content of this value, if I hash it, okay, and just call the dot as a digest. So this is the hash value of this particular content. No matter where I go, no matter what I do, yeah, talks about blockchain. Okay, cool. So no matter what I do, this is going to be the hash value for that particular block. So that's what I'm saying. So this is the hash value. This is going to be the hash value. So this content is going to be exactly what that particular hash will be. So now, how will you be able to find this hash value? So for you to be able to find this hash value is the problem.
So in a blockchain technology, let's go to the official blockchain web application to show you what is going on there. Let's see blockchain info. So the blockchain info will tell you. So let's look for the first block that exists in the Bitcoin blockchain. So this is the Bitcoin. If we come here, you can see that this is the hash value of the first Bitcoin. The first Bitcoin ever, that the block that was first mined, the first Bitcoin, which is supposed to be the owner of the Bitcoin, isn't it? It's going to be the owner of the Bitcoin that did that. Because you write an application, you're testing it, so he tested, and he gave himself £50 by just hashing this function. He didn't need computer. £50 Bitcoin at that time. Bitcoin was worthless. So now this is the hash value of this Bitcoin. If any value here changes, this value will change. So that is the only way you can track the content of this not changing, so nobody can edit it. This is just a way to make sure that nobody changing it. So this value is not going to change. So the first Bitcoin, let me explain what each of this, explain most of the parameter here. This is the hash value that makes this block unique. There's the confirmation. This is the number of people that actually say yes, we confirm that this hash value is valid for this block. So nobody is stealing it. Nobody, we did calculate it too. So some people carry out this. If you notice this is how many 0, 1, 2, 3, 4, 5, 6, 7, 8. So the higher the 0, the difficulty, that is exactly the difficulty. The higher the 0, the harder it becomes for you to hash a value. So the higher the 0, it is hard for you to find this value because you can't predict it. You have to go through serials. So this is the start, the date it was generated, the height. The height means the meaning of this height here. It means that if you have a block, we have a block 1 and block 2, block 3. So the height of this block at the moment is going to be 1, 2, and 3. As the block keep going, the height will be increasing. So it's just the index, the number of the blocks, that the chain height. And also the person who actually create this block, which is the miner. The miner here, because of Bitcoin, does not actually have to show the miner. It's going to be unknown. But there is a value that is going to be hashed for this miner, because this miner have to have an address. So this is the address of that miner, which actually include his public key and all the stuffs, and the balance and how much the miner have, and the number of transactions that the miner have done, and the balance, the final balance that is in the wallet of that miner. So that is Bitcoin. Let's go. Let me open my comment just fly, so I can see if people are actually making comments, if I'm not too fast enough to do that. Okay, guys, if you guys have misunderstanding, you can throw a comment here and we can explain it better. Okay, so the difficulty is actually the most the difficulty. When you increase the difficulty, you can increase the level of difficulty. So when you increase the level of difficulty, the way you can hash this value will be more harder. On So what I don't understand what I should throw more light to, but please, if you want to, if you're on WhatsApp, please, it will be very good if you can just try to comment on YouTube, so that will be easy for me to just reply to everybody at the same time. Believe everybody is understanding that, so please put your comment here. Okay, so if I'm going to I assume that you want me to throw more light into the block. So the block, because that's what I'm saying now. So the block himself is just like a normal block of information. So it's just like a information. It's like something that holds holds a list of transactions. Yes. Yeah. So it's just like a list of transactions. Okay, it's just like a list of transactions. So there are lists of transactions. So we know what transaction is because we use bank account. So when you send money to Mr. A, what happened is that there is going to be a transaction, and those transactions have to be confirmed. That is the idea. So for you to confirm those transaction, you have to create a block that will include this transaction into that block. That is all. So if you have more transaction again, you have to find another block. So because when a block is created to confirm a transaction, that block is closed. You cannot modify that block. You cannot do anything because at that time, from Bitcoin, let's use Bitcoin because it's the first is the main application of blockchain. So if you create a block, to create a block, you have to find this hash value. When you find this hash value, the content of the block is fixed. So if you see inside the block here, you can see that there are a lot of transactions. If you can see the transaction real life to be sincere. So let me see, only one transaction here, and the transaction that we have here is just the transaction that you send the transaction to create the block, because the guy who did this wrote it and created a transaction and award himself 50 Bitcoin, which now 50 Bitcoin, which now is a very big money. We will check the value now if you want to tell you what this 50 mean now. This 50 is big money now. So there's a lot of transaction. So let's go to the second block. I think the second block will give us more information. So this is the second block of the block in Bitcoin. Okay, the height is 2, right? The number of transactions in this second block is 1. So one person actually sent. I think this have to be the same guy again that did the same thing. If we go in, you will know he create another second block for this himself. So if we go to the third block, maybe we'll go to block 200 on Bitcoin. Something is not right here. Block 20,000 Bitcoin, 3 blocks contain 20,000. Okay, and you can see the block and the transactions. Let's go to the current block and see a lot the Bitcoin block. The current block in Bitcoin. So let's just go to the current block Explorer and go to let's go to the current block now that was just created, and you can see that there are a lot of transactions here. So this is the list of transactions. So this is the transaction. Somebody sent money to someone and it was £7. So if you send a Bitcoin now, you see your wallet, and you come over here, you're going to see a transaction among the list. If you can target the amount you send, you will see your transaction here. So if I go back and actually keep searching for my transaction, I might see it, but you might not be able to recognize it because somebody else did the same thing, because millions of transactions are going. So this block is created to confirm these transactions, and the list of transactions within this block is 2,243 transactions. So if you notice something, the zeros increase. So the zeros increases, so the number of difficulty for this zero is hard. Trust me, I know what I'm saying. To even calculate 5 zeros of hash is much, and I will show you guys this. Let's go back to the block 1 because I was still trying to explain something. I hope I explained this block of 18 because we're still going to explore the block, because blockchain technology is about block. So we're going to talk more about the block, because if you understand block,
you understand blockchain. So let's go to block 1 of this. So on the block 1, this particular the macro root of the block is that every transaction, all the transaction within the block, yeah, we will take a hash value so that nobody can change any of the transaction. So if we take the hash value, you will get this value, then nobody can take change any transaction. So that makes it more secure, because if you make a transaction, nobody can edit it, and nobody can try to change it to another amount. So because if you change it, you just make those transactions invalid. This most people talk about blockchain, they don't talk about that, but the nose value is very important here. The nose value tell you how difficult it is, the number of computational power required to compute this hash value, and we're going to do that. We are going to do that. Yeah, we're going to write a particular function to do that. You will see. So this tells you that you have to run this function. You have to keep increasing this value from 1 to this amount to be able to find this. So if I know this value now, and I add all this value together and I hash this block, I'll get this value. So the blockchain, the miners in the blockchain, the miners, people who create the block, the miners, which are the gold dealer, when they say digital gold, what you're actually trying to dig is the block. So the miners who can create the block is what they refer to as the miners, who are the gold of the current digital gold. So if you can find this nose value, this value, if you can find the nose value that you will add all together and create a block that have 0, 0, 0, 0 to this. So it's just it's more of like a game to these people. So it's not really very technical stuff. It's just a game to these guys, you know. And if you can find the value, you create the block and you get award that amount of Bitcoin. Yeah. So that is not really hard, right? It's not hard. It's really not hard to do. But because of the difficulty is increasing, since the difficulty is increasing, it makes it very hard for you to use normal computer to compute the value, because if you try to compute that value, it's going to take you the whole year. It's going to take you the whole, even your normal computer will not be able to process those power. But you never mind. You can use a normal computer to find this nose value if you want to. You can use your normal computer to find it, because you don't know where that location is. It could be just the first letter 1, and you'll have that the hash value of that, because the content changed. So this is the only value you are allowed to change most of the times, and there are few ones that they will explain. If you want to understand this, particular structure, what each field means, you can come here and actually they will explain what each part of the field means. So that is with blockchain, but blockchain technology is not Bitcoin. It's just the way it works. So blockchain technology is not Bitcoin. It's not just for money transfer. It can be used for different stuff. Like for example, you can even use it for examination, writing exam application and all this stuff. So it's just a technology, and Bitcoin was just one of the technology using blockchain technology, because it's money. Everybody want money, so everybody run after money. So if you want to be a miner, what you're going to be looking for is this value. And if you want that, actually Bitcoin have official client application that you can actually use to start mining at home if you want to. But this will require a lot of electricity to do this, because this is a lot of electrical power. So let's go back to the blockchain. That is what blockchain is all about. Trying to find the nose value of each block so that we can generate the hash, the nose value. So if you can find that value, we can generate the block. So that is what the
mining is, you have to mine for that value. You have to mine for the value knows and get the block and create the block. And when you create the block, you publish it and say, oh, I've created the block. And if you come first, you get the block. And there are, if I get the nose value and I send it, and Mr. One, if we have 5 of us that send this nose value, maybe we have 1, 2, 3, 4, 5 people that have actually sent for the same nose value to generate the block. What happened? Python will say, okay, who have the longest transaction? Who have the longest transaction here? If you have the longest transaction, definitely you win the race. So most of these people will only not just compete for the nose value, they will also want to get the longest transaction. So Bitcoin will choose the one that have the longest transaction, the more transaction that generate that nose value of the block. So more transaction means, but if you're going to have more transaction, sometimes it might be even hard for you to have the nose value. So some people select what transaction they want to do because you're going to have some transaction fees to do that. So that is for Bitcoin, but not for blockchain. So what is blockchain technology? What makes blockchain? So blockchain technology make it more secure. So blockchain technology have two things. One, crypto. Encryption. So now, what is an encryption? If I have A, B, C, D, like the English alphabet, and I write a boy, I say boy, then I don't want anybody to know that I'm writing a boy. So I can encrypt this value by saying, you know what, shift the English language by English alphabet by 1. So shift by 1. So shift it by 1. So if I have B, you add B plus 1, you will see C. So this can be C. So if you see O plus 1, you're going to see P, OP. Then Y, you're going to see Z. Now, you can write a letter, a hidden alphabet, and say UPZ. Then you only give me the key that you're using, which is 1. The key is 1. So you're telling me, hey, to read my letter, the key is shift 1 shifting. So if I have this, I know you're using 1 shifting. All I just need to do is go back, shift this by 1. I will have P, shift this by 1. I will have O, and shift this by 1. And then I'll have Y. So I was, oh, you mean boy. But ordinary person would think you're not doing anything here. They would think you're just writing some stupid text, right? This is what they refer to as crypto, hiding a cipher. So at this moment, this is called the cipher test, and this is called the plain text. So a cryptographic is to actually carry out this hidden technology. However, this is a very simple cryptography algorithm to do. Okay, so if there are more advanced ones that are going to use, but the idea here is not about writing them. It's about understanding how they use in blockchain. So in blockchain technology, all in blockchain technology, for you to transfer money, all you need is a crypto key, a key. Yeah, just a key. We don't know. We don't want to know about you. We don't need to know about you. So that's why it is called very secure. Nobody know about you. Anybody can send a message. We just need a key, and that key is going to be uniquely for you. Nobody else. It's going to be uniquely for you. Nobody else. So we need a key from you, and we need a key from the sender. So we have the sender key, and we have the receiver key. What matters is that as long as you send your money, you know where you're sending your money to, that is okay. The sender have to know your key, and I will send money to this key, and blockchain technology will go straight and send that money to this key. So now if you're the receiver of this key, if you're the receiver of this key, the money, you can get the money. You can be the only one who have access to that money because the key is with you. this is still confusing. Let me make a simple analogy to make it more simpler, because I like to explain things in a topological world than trying to bring it back to real life. So let me explain. If we're two people, okay, I'm A, yeah, and you are B, and we're sending a letter to A and B. We want to send letter to this guy, and I want to send, and he will send letter back to me. And the only way I can send a letter to this guy, the only way I'm trying to explain cryptography here, yeah, to cryptography here. So the only way I can send this letter to these two guys is via another person called C. And me and A and B are discussing about C, how they're going to key C. How are we going to send this letter? If we must send it through this C. If C read the letter, yes, how are we going to send that letter? That is one good question. How are we going to do it? How do you know? How are we going to be able to send this letter to A and B? How? So the way, let me explain. I know you guys might have a very good idea over it, but yes, how are we going to send the letter? So I can send the letter in a different way. I can buy a box. Yeah, I can buy a box that I can use big lock to lock that box. Yeah, then I'll put the letter inside the box. If you can understand this, you understand everything about cryptography, and also you understand what diction, why they say cryptocurrencies. Yes, cryptocurrency. Now, the only way you can read this letter is you have to have the key to unlock this box, because the letter is within the box. How will I send the letter to A and B? I only want A, B to be the person to read about this letter. I want A, if B send the letter, B want only A to read about this letter. He doesn't care if this guy see the letter or not, but he cannot be, he see whatever we are sending, but he should read the letter at all. How are we going to do that? So now, the first thing we're going to do is that me and B will buy a box and a lock. So we're going to have two things. Let me write them instead of key. The lock have a key, and we have a lock, and we have a box, a very strong box that C cannot open. A will have key, we have a lock, and we have a box. The only way they can open the key is the only key that can open this lock. This key is the only key that can open this lock. So what would happen is that B will send me his lock. B will send A his lock. So now A have the lock of B. I will call it lock B. And A will send the lock, his lock, to B. And now B will have the lock of lock A. Now, if A want to send B a letter, A will take the lock of B and put the letter into the box and lock it. Immediately as A lock it, it's final. Even A himself cannot open the box anymore because the box is locked. Now, we can actually send the box to C. C, even when we are sending the lock, the C cannot duplicate the lock, because if you get the lock, it cannot even get the key to open it. So we can send it B and use B to send the letter. When they send it, even if C see this box, it doesn't have key to open it. So there is no way. If C decided not to give this lock B to that, we know the message was not delivered at all, because the only person who can actually open this lock is B. This is a real life. This is how cryptography came into existence. two-way cryptographic. So now, if we send this later, if we send the later, if we send the later to B, and B and A can exchange information. But one possible way that I will be thinking right now is, what if B decided to break the bus and get the letter anyway? Have we think about that? What if B decided to break the bus? Have we think about that? What if B decided to break the bus and get the letter? This is still cryptography, the technical part of it. After this, you will understand it easily, I promise that. Now, we have to have one key. So in computing, this key that the user that A have, and the log, the key here in computing they call them primary key. So I believe anyone who have a cryptography, you will have heard about primary key, and the log is called the public key. And everybody know what because these are not real life stuff. Yeah, these are not real life stuff, isn't it? So it's computer, so we call them primary key and public key. So the main key is the public key. Now this primary key and this public key in computing, they can be the same thing. So the public key, now we just make a real life scenario of it, okay? The public key, we are not really locking anything. We're not buying a bus in computer to lock anything, okay? What we are doing is that we are sending an encryption of that data, okay? So now we have two keys. So this is asymmetric keys. So which means that if one key lock a text, to read the text, you have to use the other key to unlock that text. Yeah. If I use one key to lock it, only the other key can open it. So if I use the primary key to lock this text, to encrypt this text, to decrypt it, the public key will be the only one that can be used to decrypt it. So you get the text back. So if you use the public key, to decrypt a text, the only key that can read that text is called the primary key. So the public key cannot reopen that. Only the primary key can do the same thing. So it's asymmetric because it's both way. So it's a mathematical function. To be sincere, it's like if you have a function that gives A, and you can have a function of D that take A and give S. So you X come A and A's come B. So that's simple mathematical function like that. Now, that is how cryptography works. So how can we apply this mathematical solution to Bitcoin? That is really the question. It is interesting. How did this people take this mathematical way to transactions into blockchain? So let's go back to our blockchain. So now, before you can send message to anyone, you have to create your key, your two keys, if you want to send transaction, and your public key. So your public key, you give it to everyone, everybody, anybody at all can know your public key, but you don't want any other person to know your public key. Your public key have to be safe. You have to keep it in your log. You have to find places where nobody's going to toy, because you have millions and billions of pounds. Trust me, one Bitcoin costs a lot. So if you have that,
you're going to hide it, right? So that is the technology. So now you don't want anyone, even the closest person to you, your wife, you don't want them to have this key. This key, you tell them that I don't have it, even though you have to put it into your nose and hide it. So you give this key to anybody. Anyone want to send you money, they send you money through this key. They hide the money and send it through this key. The only person, everybody will know they send the money to this key. Maybe the public key is A. Everybody will see that, okay? Nobody cares. But who can claim it? Who can claim this money? Who? The only person who can claim this money, that this money belongs to him, is whoever have this key to unlock this money. So when I send a transaction, let's go to the beacon again to understand it, because beacon is the most popular one. I'm going to go to the latest beacon block created. Here's the latest. Yeah. So the latest block. Look at the value of beacon. So if you have that money, you know what I mean. So if we go to the latest block that is just created 10 minutes ago, somebody just created that block now. You can see that inside this block, someone create them already. They make money. So you see the money, they give it to that person. Anybody who create this block now just receive this money right now. Bitcoin. I'm going to set pounds because this is where I am. So it's about 267,000 pounds. So that's what the person have now. So that is the latest created beacon, and these are the transaction. So somebody send this transaction. This person send this particular transaction, right? So if you send this transaction, the transaction should actually have who send it, from who this transaction is coming to, and to who the transaction is going to. Okay, so and this is the hash of the transaction. So let's see from who this transaction is coming to, account. So the address of the place that this transaction is taken to, you take a snapshot because you didn't show the public key, isn't it? There's no, the public key was not showed, yeah. So, or maybe they take the address. We can ask what the address is actually to understand it better, then to who the transaction is going to. So the total received money for this transaction, somebody sent this transaction, right? This is in millions. Somebody sent this transaction, so it's open source. The total send, the final balance. So this transaction went to this guy because this guy didn't send it. So he received this money. So this account received the money. Yeah. Now if we go back to the set transaction to who is coming from, let's see who is this transaction coming from. Total send and total receive. So you can go deep and just look at what people are doing there and make it in thousands. So people are sending money, so you can make it in Bitcoin in pounds. Then again, now if I send these transactions, all these informations and everything, so I'm going to encrypt some information for that transaction. One is that in cryptography, we use the word sign, digital sign, and believe everybody have heard about this, digital signation. So how does digital signation works? So digital signation is when you use the primary key that you have to encrypt a text. You use the primary key that you have to encrypt it, and for somebody to confirm if it's really from you, they have the public key. They know where they get the public key for. Okay, the only person who can encrypt it is somebody who have your public key. So there can be many of them. So it's just a confirmation to say, hey, is Obaro gave us this public key. So is this message coming from Obaro? If the message is coming from Obaro, I can use the public key to decrypt it. If it's not coming from Obaro, I cannot use the public key to decrypt it. Then I will know that Obaro is not the one to send this message. So if I'm going to send the message now and I send the message through this and I give you my public key, please
remember that this is my message. I can send you an hidden message and I'll give you a public key that you can use it to open it. Yeah. So you will now know that that is me. So it's more of another layer of security, and that particular way of confirming you encrypting the message is called, it means you, with your primary key, mean you are signing that later. You signing the later because you don't mind, you don't care how many people goes, how many people receive that later, right? That have your public key, the authorization, you give them the right to have it. All you just want is that signature, you're using that signature to say, hey, I am the one that have that. So these people are just a confirmation. So many people, anybody can have it, just to confirm that you have it. But if they use their public key to send a message to you and encrypt a message to you, at this point they call it encrypting. It's not signing because they hide it down later, not just for any other person, only for you to be able to read it. So this is encrypting. So you can, the only person who can read it is primary key. So now if I have your public key and I send you £20 and I put the sending reason why I'm sending information, maybe I put some message or something, and now I take the hash of this transaction and I use your public key to hash that hash value, okay, or hash the content of that transaction, so that now nobody else, because I've used my public key to, I use your public key I use my primary key to sign the hash of this content. I told you what the hash is. We're going to go back to a hash in a more technical way. So we hash the content and I use my primary key to hash it, which means I have signed it, that I am the one sending you that message. Then use your private key to encrypt the message, your public key to lock this message. Now, other people can see the money, see information, but the only person who can claim this money is the person who have the key, the primary key to unlock this transaction, and it's going to be you. So when this transaction is confirmed, you can claim your money. That's exactly what Bitcoin is doing there. This is so weird that you can't understand it unless, that is the reason why I say learn how to program like a professional, because if you don't understand this, you can now program this information. So the channel here is to talk about Bitcoin, and now you have some basic knowledge of Bitcoin. And the technical part is this cryptological part of a thing. That is Bitcoin for you. That is Bitcoin. Okay. That is Bitcoin data. So now, what this technology, Bitcoin, is the blockchain technology I just explained. As I said before, Bitcoin is just implementation of it. So what can we use this Bitcoin to do? Again, we can use this Bitcoin to do this blockchain technology to do a lot of application. So there's one of application that I really tell people about that is good. So if you have, just imagine you want to do another application that is not in currencies or anything, or maybe you have an application that who first guess a number. So, and if you guess the number and you're the one that proved that the people who guess the number are correct, so who first came to class attend the list. So in every attended list, you can create a blockchain for those things. So you come, you sign in, anybody who came, you sign in, you come, you sign in. It doesn't have to be money, all about money. Everybody who came here who signed in can be the transaction of that day. Yeah, the signing in into the class is a transaction. At the end of the class, you can close, you can create a block that will have all these transactions and save the block, so that even if somebody came back and say, hey, please, I want to sign in, the block is already created, he can sign in, is out of this class. and any penalty they have to go to him, he have to sign it into a different transaction. So every time a class finish, you close it, you save it, and this can be an implication of blockchain technology in signing system. So you can actually use blockchain technology for a lot of things, not just currencies. You can use them for a lot of applications that is going in my head right now, but I don't want to list all of them. But one of the challenging things is that if you understand the basic, you can actually go further by going to Google and ask a lot of questions and know how the basics works. So that is a simple way of blockchain technology. Blockchain technology is about creating block with a lot of transactions, and for that transactions you can create, if you have a transaction, pending transaction, which they call it, many transactions, for you to be able to save this transaction to make it more secure so nobody can come over and change a name or change the certificate value or something. You can create a block, store it, hash all the transaction, get a single hash, which is the Marcus key of this transaction. Then you can hash it, and whose number you can keep going it. If you want to play more game, and you can say, okay, you know what, anybody who is going to confirm the list, who is going to be submitting this list of attendance to us, you will be earning like £1 every day. So you can make it more fun so that people will be very interested in creating more block for you in every attendance of that. So it's just a game. There is nothing to it. Somebody just get bored and create this game, and all of us are following their track, and they're making millions out of it. Oh my dear. Did I choose the wrong feed? I should have just created one of these, right? Okay. That is said. So life is not as serious as we think. People play game and make millions. So now, how are we going to use this technology? That is the reason why everybody have to learn how to code. Programming is not just for people who study computer science, it's for everybody. And programming is simple. The guy who creates blockchain, he understands what he wants to do. And for him to actually make it an application, he needed to learn programming language. And there is a lot of programming language. You don't need to be a professional here. It's just a set of instructions. A programming language is a set of instructions telling, just like what I described right now in an English language, right? So I want to describe it to the computer so that other people can be using it. So how do I describe this procedure to the computer? Let me show you how. If you're still interested to learn, because I still have some few minutes to go. Now I am going to create a programming artifact that will behave like a block, and another programming artifact that will behave like a transaction, right? So, and I will create a way of me signing the content. Let's go and read how blockchain actually sign the content to tell you. So, how block Bitcoin. So Bitcoin as hash. What values, what feeds do Bitcoin hash? So if you go here, you can see anybody who wants to describe Bitcoin for you are actually using programming language. They came here and they use a programming language. If you're familiar with this, I actually bring this programming language out. I use this in library. So how does Bitcoin know what value to hash? Look, here the Bitcoin, according to this guy, if you read it, that the Bitcoin will hash the version number, hash the previous block number, hash the macro root number, which is the list of all the transaction block, and the timestamp of the time time that block was created. Current blocks times that are seconds since this and this. Every few seconds, this value will change. Bits, the current target in the compound bit, the difficulty is adjusted. So the news value is the value that you will definitely change. And you can actually hash it. I don't know if this is exactly how it works because I don't have access to the code
and I've never read the code, so I'm not going to say this is correct or not because I've never tried it. I'm just putting this based on how I understand blockchain. So I might not be correct that this is correct, but I'm going to tell you what we are going to do. So if you want to really write an application, you can write a simple application, because most of this, if you want to do a blockchain technology by trying to write an application that will transfer money and actually create your own blockchain. If you want to create your own blockchain, start small, start very small. Most people think, oh, this guy is very smart because he wrote this programming language. Really, how smart is that? Yeah, he's good. He's a thinker. He's a creator. He understands what he's doing. Yes, that is smart, but it's not as smart as a lot of people said he is. But he is smart because he make money out of it. Yeah, look at me. What did I do out of it? Nothing. I'm just giving a tutorial out of it. But that's true. That's true. Beacon is as simple as we thought. You can get it done. You can get it done if you create your own ways. So every block is saved into a block. Okay, this is a block. Let me assume I'm going to create a JC format. Then this is how you describe. This is a simple file. I just created a file called Account Johnson. So each block, I'm going to create every file is a block, right? Then every user, I will have the user key. That is the key you see. Something I will generate. Then I will store the public key of the user. I can store the public key. Public key of the user. And now you can have the public key of the user, or you don't need to actually have the public key of the number, because when you create a block, so let's assume that this is the block. So and we come over here and just copy some information from the let's read. A block is found. Okay, let's go back to this. Where is it? So we go back to the block. Where is the block? Beacon Explorer. Another block 6 minutes is created again. You can see the value is increasing, the block height. So then a block have number of confirmation, the hash value of the block, and the time and the height. So we're just going to take a random value. Okay, so we can just show you how a hash work, how mining really work. So it's not as easy as most people say. I think I wrote a program that do that before. So should I be able to find that program, I could just run it to see. Otherwise, we have to write a new one. So let me just write a quick function. I don't expect you to know this, okay? I don't expect you to understand what I'm doing now. It's just for you to just understand what is going on. So let's just create another function. Like, do I create that function? And I will say hash. Don't understand what I'm going to write now. Just hash content. I'll call it hash content. Okay, I won't do that. So I won't do that because I have a function inside this class. So if I run this, if I import this value, I can actually do it like that. Let me see. So if I import this value here, I can create this object. I can say repo, because there is, and I say testing dot text, so it's going to create text file anyway. So there's a function already that I've actually created here. Say create hash. This create hash will take a content which is any value. So I can say borrow, and this function borrow, because it will take it in a string. I don't expect you to understand this, so please bear with me, so that it will return a hash. But there is no zero. So the idea here, the major work here in a blockchain is how you can hash a value that have 20 zeros. So I'm going to create a function called hash with difficulty. Yeah. So and I'm going to say the difficulty is going to be the number of 0 at this point. Yes. So let me say the difficulty. The difficult will be
let me make it short. Difficult will be an int value. So the difficult of that particular content of hash, the content is going to be in a string, any content. So we want to add this content. We have created a mathematical function, and now we are saying that if we give you a content, and we give you a content, and we say the difficult of that content, we will start with 0, right? The difficult of that content is 0. Then no, we don't expect you to have any zero. But if we say 5, we expect you to have 5 0. If we say 10, we expect you to have 10 0 before any value. So now let's go, and now we're going to return. We're going to have our result. Yeah. So the first result is going to use the repo to create the hash. Yeah. So we're going to just copy this value here and put this here. So the first thing is that because we want to do different content. So the first thing is that we'll take a content, we hash it. Okay. So now, in every content that we take, we're going to get the first. We're going to, okay. Oh no. Let me copy this first. So I want it in any content. I want to have. If I say 2 difficulty, then 2 0 will be, and we can have something like this. If I say 5 difficulty, we'll have 5 0. If we have 10 0 or 20 0, so we're going to say difficulty. The first time I want to create a function that will just return the number of zeros. So if we say get zeros, yeah. So get zeros. So get 0 will be a function that will return the number of 0 we want. So if we say number of zeros, so if we say number of zeros, so we're going to get 5 zeros. So let's just make it very simple. I don't want anything hard. So it's going to be result, and it's going to be this. So it's like pending. So you say for I to. I don't expect you to understand this as I say in range. You don't understand this, just know that it's a computer program I'm using to tell this guy to do what I want. So I'm just going to have the number of 0 that I wanted here. Okay. So as you count it, just keep returning the number of 0. So let's do this. If we say get 0 and I say 1, it's going to return 1 0. Get 0 and I say 0, it's going to return nothing. If I say get 0 and I say 10, is 10 is going to return 10 zeros. Cool. So now we have a function that can just bring a 10 0 for us. So let's create a function that can make it difficult. So we wanted to create a hash. So from that hash, we're going to be getting a function that will get us the number of zeros that we want. Zeros that we want is we'll call the other function to say is the number of difficulty that we want, right? So now we want to make sure that until we generate a hash value, now we're going to be returning nose value of this. So the nose value is the number we're going to be increasing. So we'll start from 0. Okay. So now until we return, we use the statement until y. Y0 is not equals to the hash value, of this. So we have the content. So how do we have a hash value? How do we have a number of strings? So I'm going to copy this again. I will stop this. So if I have a value like name as a Obaro, and I want to return OB only, I can say, I can substring it, I think. I can substring it, or I think I can say name the substring, yes, 0 to 1. Let me see if that works. Name the substring 0 to 1. That doesn't work, so we can go it. Let me just go it and show you Python substring. and substring, get a substring, so you can get a substring. I don't want to use this, but anyway, it seems that that is the only way I have to do. So if I want to do substring, I can do a substring 0 to 1, and it will return OB. But I want names of string 0 to 2, so I need 2. So it will give me OB. So now that we understand how substring works, okay, so I want to say the number of zeros. How many number of zeros do we have? The number of zero from 0 to the number of difficulty. Is it equals to? Is it the same? If it's not the same, what will happen? We will increase the nose value. So every time we encode, we find a hash of this value, right? Every time we find a hash of this value, so the content. Every time we find the hash of this content, the content will be, we will append this content. Let's do it this way, okay? Append this content plus the nose value. So the content will be here and the append value will be there. So the nose value will definitely increase. So every time we encode this content, if it doesn't match, we increase the nose value again. I'm going to show you what programming is. You say equals to 1, we increase it by 1. Then now you carry out the same thing again, and you find the result again. So until the first value of the hash have the number of 0 that we want, which is the difficulty. So if it have the number of 0 that we want, so what I'm going to return, I'm going to return both the hash and the nose value. So okay. No, that's not exactly what I want. I'll copy it again, and I will do this. So now when we have it, we're going to return the nose value and the result. I think that is exactly what should we do. This is quite a basic function. This is not exactly how many, but this is exactly how Beacon is doing it. Okay, you can write a different algorithm to make it faster, but this is exactly what is going on. So if I say borrow this time, and I hash it, and I leave the host value if I don't put 0, and I just hash it, that is okay. The nose is not defined. Format nose value is this. What is not defined? I'll copy this again. I think something is going on there that is not defined. So I'm just going to say that is the value, yes. And it said this value is not, it doesn't know what this value is. So let me copy and paste. Maybe I'll do some spelling error there. Okay. So yes, so okay, so now let's do it again and do this hash. Let me just say borrow. Cool. So if it is 0, you can see that this is the hash value that I have. So if it's 0, so now let's do borrow again and say, no, we want you to have some difficulty, so we want you to return 1 0. So this value these two have to be 0 and plus any other value. So 1 0. So let's see what happens. Okay, this is fast. So this is still fast. So we have 1 0 now, and the value, the content change. Can you see this? So this is what we're going to hash. So you're going to see as long as we're going more, the difficulty hard. So let's say we want it to be 2. Now you will see we take more. So we go 57 times before we actually have it. So it's 2. So this is still fast, okay? So let's say we want 3. You will see this. Oh, now it's a little bit slower because it went to 7,000, the nose value. So we want to go back again and do it to be 4 to say. I believe my computer can only do up to 5 or 7. So you see the exponential decrease of computer power that required to actually compute 4. So let's say, I don't really know when it's going to stop until it's going to find the right
value with 4 zeros, this is not going to stop. So you see, 3 was even faster. Then as much we go to 4-0, it becomes harder for this function to find. So he will go through millions. I believe he's going to find it. It's just going to take him time. He's going to find it, but it's going to take him time. So this is exactly what they call the mining. It will take you time to find it. So this is exactly what the mining is, and this is what blockchain is. So if you can find the content of that, content of a barrel with the 57, now we can answer. I think this is going to take time. So that's one of the very difficulty to do, because the mathematical difficulty, this is exactly the mathematical difficulty. So if you're very good in mathematics, you can design another algorithm that can do it faster than this one. So guys, I think I'm going to leave now, because Bitcoin is a very good thing to talk. I hope you guys understand it. The next time we're going to talk is how we can actually start building this knowledge that we have, this pre-knowledge. We might visit it again and talk into more details of this particular Bitcoin. But for the now, I think what we should do is get a little relaxed. So the next time we come, we might learn how to really code. So I might want to teach you guys how to code, and also how you can actually implement a blockchain. So for the moment, I don't assume I don't expect you to know what this programming language do, but the idea I'm trying to pass here was that the higher we go, the more difficult it is for the computer to find the hash value, because the hash value, nobody can actually know what hash a particular content will be. So I'm going to So I hope when you watch this video again, this video will be published. You can listen to it. I might be very fast in trying to get all the information within the particular time. But even though I was 4 minutes away, because I thought I'm going to just spend an hour to do this, but yeah. So this is the idea, and you can see my computer is still running. I think I should key this if I can. But if I'm going to key this, I need to copy this somewhere else first. Let me do this. So that I can show you something more before I leave. So I need to copy this function again. Where is the zero function? The one that defines the zero and the one that really works. So the 0, 1 here again, and here, and I will call it hash finder. Yeah, so I can stop this because, oh wow, definitely, see, I was trying to stop it and he actually find the hash value, and look the number of computational power he used, the number of iteration before he can be able to find 4. This is how difficult it is to actually find the values. It's how difficult it is. So just imagine I change this content a little bit to about 1, and let's do it as number 1. You can see that the value will change. So you can see this is exactly, and the way it changes is very different. You will never know that this is the same name, so the generation will be different. But every time I run this, it's going to give me the same value. So hash value, every content have different hash value. No matter what the content is, they always will end up having different value. Maybe one day someone will be able to generate a content of different that have the same hash value, but it's impossible at the moment. So that is one thing. So if I change this content
even slightly small like a dot, the value will change randomly differently. You will never believe how they change. So it's very hard for you to predict what nose value that you're going to find to do the hash. But now that we have the nose value of this and the nose value of this, I'm going to modify this function. I'm going to write another function that will say get a hash content. Get hash content. So you give him the content and the nose value, and it will return the same hash value for you. I'm going to get the hash content with the same thing that I did here, okay, so that it will be the same. So now instead of, because here I say create a hash where the nose value is 0, what did I do? Oh yeah, so where the nose value is 0, you get the content and you get the nose value, then you code the content, then you return the result. Yes. So now what I just did now, so if I have the nose value, I don't need to go through those computational power anymore. All I just need to do is get, so let's try for this. I get this Obaro, and I give the hash, the nose content is 57, and I expect him to give me the same hash. No, where is it? No, I expect him to give me the same hash value. Where is it? 57 Obaro 57. So he didn't give me the same hash. I gave him 57. Did I do something wrong with my function? So this is the host value 0 0 content, the hash content, encode this content and return the result. Yes. So what did we do wrong there? We didn't do anything wrong, right? So the host value is 0, the content is 0 and 1. So the same content that we have. Create a hash. You create a hash. So this is the content and the nose value. Then you create a hash and you return it. So that's exactly what we did, isn't it? Content and the nose value. They'll get the content. They will create the hash of that content and return it. So 57 should give the same answer unless something is wrong. So if I want to create the hash of this, I give the content 0 and the name is for this hash is that and the content is that. Okay, that and the content is this. I should get the same also value, so it's not giving me the same. So something must be wrong with our function, because what do we add to give us this? Something must be wrong with our function. So all we are doing is checking this difficulty. If the difficulty is not equals to, we'll return the hash until you get. So we change the value a little bit so that you can get it. So let's go back and write this function again. You have to. So I'm going to put it here again. So to make sure that we're not making mistake before we go, then I'm going to import this particular function that we're using and that, so that we don't miss it, like that, and get that. Okay. So let's see this function. If we get the host nose value, we want to give this nose value and the content again to give us the hash. So what is happening here now is that we get the nose value and the content. It gives us the content, the new content, the content, and inside the content we encode it and create a hash. Then we will check if it's equal to the zeros. If it's not, we increase it. We put the nose value again and get the value. Okay, that we're doing wrong because we want to be getting this value. So sorry, that is wrong, so that is why I know why now. So we have really big error here. So this content should be new content. So the new content should be what we should be encoding, right? So we get it, we check it. If the new content is not value, we get the new content. Now this content, we don't want it to change because we just only want to change the host value. So if the new content, we change the coding, I will do it until we get the right content. So the same thing will happen. So that is exactly what we want. So let's run it again. So if we run for 5, I think we do 1, we do 2. Let's do 2. Let me close this to make it clean, because that particular mathematical function was full of errors. So we have this. So now we can say get hash content. So we get Obaro. Now if we give this 95 to it, we can return the same content. Yeah, now we don't need to do all this computer power anymore. So if it took us very long time to do 4 the other time, so let's see if we can do 4 quicker this time because of the way it works. So we were able to do 4, and the host value is that. Now if we have that content, we don't need to run it again because now we have the host, the nose value. So we just give it and it will give us the content. So the nose value is exactly what you're mining. If you can mine that nose value, it will be great. So if we go back again and do 5 will take longer actually. So yeah, so yeah, it took a little bit longer. So you can get that content. So now if since we already know the content, we don't need to do that mathematical function anymore. All we just need to do is get that content. So you can make it very hard for users to create an account by generating using blockchain technology, which is this particular hashing. I think that is the important part of the technology that is interesting for people to join because they want to find hash to get money. So this is what you find to get money. So this is 5. So it doesn't matter what content you use to get that 5. You can generate a content long. Since I can calculate 5 here, let's see how long the content to generate. Who want to be a billionaire? So a billionaire. If I generate this content and make it fast, it's still going to give me value. But look what happened. Obaro with 4 gave us this long host value, but this long value gave us even the short value. So you can't predict it. You can't predict it. That's the interesting part. I wish I can and just make money. So that's the idea. Hope you guys enjoy. I'm going to go today now because I need to take care of my baby boy. Bye for today, and I hope you guys understand what simple blockchain means. And if you cannot understand it, it's not your fault, it's my fault. And the next time we might talk more and more, but please put your questions in the comment. Make a comment and let's talk about technology. And also tomorrow, the next time we're going to stream is going to be Saturday again, and we might just start introduction to programming. If you understand programming before, this is not for you, but you can stay with us because we don't want to actually teach programming just like the way they teach it in school. I want to be able to bring programming in a way that you can use it to do real life job and also start writing mobile application and writing your own algorithm like the guy who created blockchain does. You might have a very strong good idea of what you want to do, but as I said before, everybody should learn the programming language. It's the language you can use to communicate with computers, and you have to understand that language. If you understand that language, if you're the person who know
biology, it's very good to use that language to express your biology, to understand what biology really is. Then if you're a mathematician, you can use it to write mathematical models to understand the concept within your maths knowledge. So it makes you understand a lot of things. It makes me understand a lot of mathematics. So I think it may make you understand a lot of things. And let me tell you something. When you understand these things, you can create things for people to use, and you can make your own millions. Being a programmer, you will always having creative mind to make money, no matter what. And the joy it brings is very, very important. Thank you for listening. And